Assalamualaikum warahmatullahi wabarakatuh. We are from 2 BMMV 1/1. We are going to present our assignment for BMMH3553 heat transfer subject. So the title of our assignment is Conduction Graphical Analysis on Heat Transfer. As you can see here, these are my team members. My name is NURUL HAMEDY, matrix number B0919100020. Next is content. We have 5 things to present in our video today. So for the first one is introduction, second one is selection design, next analysis, discussion, and conclusion. For the conclusion, we are going to conclude which fins is much better. So for the introduction, as we know, heat can be transferred into 3 different ways, such as convection, conduction, and radiation. Heat is the heat transfer through the methods without bulk motion, which is from energetic to less energetic particles due to the interaction between the particles. More energetic to less energetic means from higher temperature to lower temperature. Conduction only occurs when two objects with different temperatures come into contact with one another. So for this assignment, we are focusing more on conduction since we need to come up with two design of fin surfaces. So we choose to do the CPU fin so that it will help the heat circulates from fin, so the CPU will cool faster.
Hi, my name is FARHAN. Okay, in selection design, there are two design of fins that we make. The first one is aluminum alloy, the next one is copper. I will explain the measurement of both fins. Okay, both of them have same base measurement, which is 30 times 30 times 1.81 millimeter. Both of them also have same height of fins, which is 10 millimeter. However, both fins have different shape. Aluminum alloy use cylinder shape with diameter 1 mm, while copper use cuboid shape with volume 28 times 2 times 10 mm. The cutting part area at the middle of the fins is 1 times 5 mm. The distance between fins also different. Aluminum alloy use 1 mm, while copper use 2 mm. Before heat simulation begin, both of fins must combine with stainless steel base first.
Hi, my name is Nazran. So I will explain about analysis. Okay, fins are thus used whenever the available surface area is found insufficient to transfer required quantity of heat with available temperature gradient and heat transfer coefficient. In the case of fins, the direction of heat transfer by convection is perpendicular to the direction of conduction heat flow, as we can see here in the picture below. Fins are commonly used in heat exchanging devices such as radiators in cars, computer CPU heatsinks, and heat exchangers in power plants. They are also used in newer technologies such as hydrogen fuel cells. Nature has also taken advantage of the phenomena of fins. Heatsinks are used to cool CPUs, GPUs, and some chipsets and RAM modules. Thermal adhesive or thermal paste improve the heatsink's performance by filling air gaps between the heatsink and the heat spreader on the device. A heatsink is usually made from aluminium, copper, and many more. In our project, we try to focus this prototype in modeling the fins for RAM. By using stainless steel, copper, and aluminum as the materials, we are going to compare which have the highest conductivity of heat, temperature gradient, and heat transfer coefficient. For the base, we use stainless steel material for a good power supply's conduction. Then, for the fins, it is made of alloy and copper. Why there is two types of material for the fins? It is because to determine which have the better conductivity and have a better air circulation.
Okay, hi, assalamualaikum and sejahtera. My name is ISKANDAR. I'm going to talk about the discussion for the assignment. Okay, so for this one, copper fin, there's 5 types of color. The first one is the blue one, turquoise, green, yellow, and red. Okay, so here is the graph. Okay, as you can see, the red one is the highest one. So it means the temperature is very hot, and the temperature show it's around 99.8 degrees Celsius. And at the blue one, it show that the temperature is 99.2 degrees Celsius. Okay, so let's check for the thermal loads. Okay, for the thermal loads in this process, we use two types. The first one is the convection, and the second one is heat flux. For the convection, we use the data as given, which is 5.03 uh, watt over meter square kilo, and for the heat flux we use 1500 watts over m square. Okay, alright, for the next one is the aluminum alloy fins, or we call it as cylinder fin. Okay, as I mentioned before. Okay, this one is for the blue one, followed by turquoise, green, yellow, and red. Okay, for the red one, the hottest one, we get it's around 81.2 degrees Celsius, while for the blue one we get around 80 degrees Celsius, which is it's more better compared to the copper fins or brick fins. Okay, for this one also we use same as before, thermal loads, which is convection and heat flux. Okay, for the convection we use 5.03 watts over meter square, and for the heat flux we use 1500 watts over m square. Okay, so for the heat flux, we put at the bottom of this prototype, and for the convection we put around the prototype, except for the bottom, because at the bottom we use only for the heat flux. Okay, that's all for my discussion. Thank you.
Okay, for the conclusion, as you can see, both models have temperature in range of average temperature on hot side and cold side, which is between 76.7 and 97.3 degrees Celsius. Based on the graph, aluminium alloy fins has lower average temperature compared to copper fins. Aluminium average temperature is 80.6 degrees Celsius, while copper is 99.5 degrees Celsius. Aluminium alloy is better fins for RAM because it has lower thermal conductivity and excellent heat conductor compared to copper. That's all from us. Thank you.